My name is Callum Hughes. I'm the Principal Solutions Architect for Amazon Studios. You may have heard of Amazon Studios, or you certainly, hopefully, have heard of some of our shows. We're the people who are responsible for making TV shows such as Man in the High Castle, The Tick, The Grand Tour, Red Oaks, Transparent, and movies such as Manchester by the Sea, The Salesman, The Wall, and a whole bunch of others. Originally, when we gave this presentation last year, the title was actually Encoding Artifacts to the Emmys. But because we managed to scoop 3 Oscars this year, we just sort of changed it up a bit. We won an Oscar for The Salesman, and we actually managed to win an Oscar, oh well, 2 Oscars for Manchester by the Sea. So kind of neat for us, and so we wanted to kind of change the emphasis just a little bit there. We're going to talk about the kind of things we have to do for 4K content and frame it in a kind of simple and easy way to visualize. All good reInvent talks do this. They typically start with a problem that you have to define and kind of think about the ways that you have to solve them. And in this case, it's actually pretty easy. So here we have the problem, and there we have the problem. So it's really that simple. It goes from being a small problem to a much, much bigger problem. And that problem really is size. And the way that size impacts something like a studio, like Amazon Studios or other studios out there, 4K actually makes really, really big files. Because obviously there's a lot higher resolution. This means that there are, inherent problems. Anybody who's worked in the production and post-production environment will tell you that deadlines and time never get wider and longer. Deadlines always get shorter. And so this compounds the issue of the problem being bigger, because stuff takes a lot longer to actually process and put through the entire workflow that we use. So in some instances, the problem itself is the same, but it's different because the impact of having 4K resolutions compounds everything. And so we have to think about the solutions in different ways. So we're going to cover 4 basic things during the course of the next hour or so. We're going to talk about ingest and what that means. We're going to talk about storage. We'll look at some processing stuff, and then we're going to get to the distribution point. And we'll cover some of the things and techniques that we've done at Amazon Studios, but we'll also talk about some other third parties as well who've had to address very similar problems and challenges. So to visualize this in a really kind of effective and simple way, this is what resolutions look like. So as you can see, the old, most popular format was obviously DVD. And that would give us 480 or 576 vertical lines for content. So you can see it there on the bottom right. But then when you look at 4K, it's 4,096 vertical lines. So straight away, it's a massive jump in size. And I don't even want to begin to think about 8K, because you know that's coming, and you know that's going to be twice as big. So whilst I don't want to think about it, I'm already kind of like mulling it over. And it's a little bit terrifying, but we'll figure it out. So let's put this into kind of like a data representation. So if we think about bit rates and file sizes, on the left we have HDTV, which was pretty awesome, and it was a whole kind of new way of looking at content, and it definitely made us feel good when we watched it. You can see that a mezzanine file, which is essentially the file which most studios will work with, for mezzanine file is a lightly compressed version of the video asset that you have. From that, you can do other things with it. You can use it to create other versions and so on. So this is the one we really care about. You can see with HD, you'll be getting at about 25 gig for an hour worth of content. When you jump across to 4K or UHD, it becomes 1 terabyte per hour, there or thereabouts. So these are kind of big numbers, especially when you're thinking about a global distribution like service like Amazon Video or Netflix or Hulu or something like that. So when stuff goes global, you introduce a whole new realm of problems that you need to think about. But these underlying issues don't just magically go away. They actually get, obviously, a lot worse. So let's talk about ingest. For us at Amazon Studios, we had kind of a conundrum. So Amazon Studios is actually very new. We're only 3 or 4 years old. So in terms of historical studios, we're kind of the new kid on the block. With this, introduce some other things in addition to the problem. It's not just about size for us, and it's not just about having legacy systems that we need to think about. In fact, we were free of legacy systems. We didn't have to worry about that because we are new. So we literally had nothing. So our infrastructure was, from scratch, which was both good and slightly terrifying. because obviously we didn't have like the old comfort things we could fall back on. We had to create everything from scratch. Things were more fundamental for us, not just about size and the problem being big. We also wanted to be able to do stuff quickly. So you remember right at the very beginning, I mentioned that the problem impacts deadlines and time constricts in the world of production and post-production. You never get, longer and longer goals in terms of like your deadlines. People want their content produced, they want it spend as much time as they can in production, and then so post-production ends up shrinking and shrinking and shrinking. All the while, that ginormous file keeps getting bigger and bigger and bigger. So we needed to put in a solution which would give us control. It would help us to kind of figure out where things are coming from, how we can move things around, how we can make sure things are secure, how we can give the best possible treatment to the content which we're receiving. Because obviously Amazon Originals is considered the flagship content for Amazon Video as a Service. Like, this is the stuff which differentiates us from other providers. So shows like, the Grand Tour, like that's a reason people will actually watch Amazon Video, because the Grand Tour is awesome and hilarious, and Jeremy Clarkson and everybody else on the show are pretty funny, apart from Captain Slow, he's funny too. But those are the reasons that people want to watch stuff. So we wanted to make sure that people are actually able to spend as much time in production as they could and be as creative as they could, which meant that we had to figure out ways to actually make stuff faster wherever possible. So this is just a quick overview of the kind of challenge that we faced in terms of a workflow. So at the very top is the first stage. So this is ingest. Ingest is when we bring in the assets that we get delivered by our content providers. We run some QC checks on them to make sure that they are, for example, filmed in the resolution that they need to be filmed in. Then we have to package up the assets into a deliverable. So we create a package which will have like manifest files and so on. We check that, make sure that's as it's supposed to be. And then we move into the delivery cycle, which is where we actually deliver this content to Amazon Video ready for distribution. And then the final piece is archival. So if you've ever worked on a show or production, or if you haven't, you would be amazed at the amount of assets which get created in the duration of a series. To give you an idea in terms of context and size, I recently finished archiving season 1 of one of our shows. And it was somewhere in the realm of 200,000 to 300,000 assets just of footage. So this included things like drone footage, stills, audio files, text files, you name it, it was in there. And it came out to about 18.5 terabytes of data, which presents a problem in terms of size too. Because like when you start archiving that many assets, that's great, but then you have to figure out, well, what does that mean? Like, how do I get to them? How do I find what I'm looking for? And we're going to talk about how we do that a little bit later on. So workflow management is a key component of whatever solution you put in place for 4K content creation, especially in the cloud or in AWS. But you also have to think about like your users too. So who gets access to the systems that you build? So for us, it means not just post-production, who are the people who do all of like the finishing stuff on our shows, but also PR and legal and marketing. Like they need to be able to get these assets too. And marketing is super important because obviously you'll have seen already, we're already doing teasers for season 2 of the Grand Tour. And so that's without the stuff actually even being fully finished yet. But marketing gets early access because we want people to be aware that season 2 is coming. And then the second piece is the distribution of those assets. So obviously we've quickly covered delivery, and that means putting stuff out to Amazon Video or whatever distribution channel we're using. But also localization, which is a huge, huge problem. But it's a good problem, but it's a problem nevertheless. So localization is something which is key for any globally available video service. So if, for example, you're an Amazon Video customer and you want to watch the Grand Tour, or you want to watch Bosch, or you want to watch whatever show made by Amazon Originals, you want to watch it in your native language if possible. You don't want to have to, try and understand English if you're not an English native speaker, or, if you can speak English, you want it in your own language. So this is where localization comes in. Localization is the process where assets are sent to a localization company. They will employ actors who will record the new audio files, and they'll also generate the subtitles that you need too. So that actually sounds relatively straightforward, except that there are little things that will catch you out with localization. So it doesn't sound hard, but it's actually kind of like herding cats. So you can't simply have any actor from Germany be the voice of Jeremy Clarkson. The actor that plays Jeremy Clarkson's voice in Germany is well known, and he's recognizable. So that means that you have to make sure that your schedule ties up with his, and you're able to kind of get them at the right time. But all of this is squeezing the deadline and the timelines that we have to get this content ready. So again, this is where that big problem of size, which doesn't seem like it could be a big deal, actually has a massive impact on the post-production side. It's especially hard, too, for kid shows. So kid shows are often voiced by children. Children go to school. So that means that if you're on a tight deadline and production is happening and post-production is happening when the kids are at school, that's a problem because you can't pull them out of school, right? So that's another thing that has to be factored in. But I wanted to show you a quick video just to kind of highlight this point. This is taken from one of our shows, and it kind of like exemplifies really the type of stuff that happens. And there's a quick question at the end, which is how many languages are encountered. So here we go.
Tell me about this statement from Mr. Holland, Detective.
We were packed up, leaving. Camera was off. I was the last one out because I needed to give him a copy of the search warrant, and I did so at the door.
Señor Fox, ¿fue testigo de eso?
No, estaba al teléfono, señoría, en otra habitación.
Holland me preguntó si habíamos encontrado lo que buscábamos. Le dije que no, y mientras íbamos hacia afuera, dijo, y tampoco lo hará.
Parece que ele estava afirmando a inocência.
Essas foram as palavras, mas não foi esse o tom de voz.
Tom de voz. Excelência, por favor.
Deixa ele concluir. Qual foi esse tom?
バカにしてた。あの時点でホランドさんは被疑者でなかったのでカマをかけたんです。あなたがやったんでしょって。
Lui ha sorriso e ha detto, e la passerò liscia anche.
Vostro onore, nessuno ha ascoltato questa presunta conversazione, eccetto Bosch.
E non è tutto, ha detto un'altra cosa.
Vada avanti.
Il signor Holland mi ha guardato e ha detto, sono un dio in questa città, detective, e non si scherza con gli dei.
Es ridículo. El detective Bosch tiene todo un historial de faltas en
Su
investigaciones.
señoría, las frases voluntarias del acusado fuera de la corte son una excepción y pueden usarse contra él en un juicio.
Elle a raison, Monsieur Fuchs.
L'inspecteur Bosch a inventé l'intégralité de cette conversation.
Et vous pouvez vous en prendre à la crédibilité du témoin, le jury tranchera. C'est ce qu'on appelle un procès.
Nein, alles, was Sie dazu noch sagen könnten, habe ich schon x-mal gehört. Das führt zu nichts. Ihrem Antrag, diese Aussage auszuklammern, wird nicht stattgegeben.
Alrighty, so aside from seeing Titus Welliver flick between these languages really simply, it kind of shows that like there's a whole bunch of stuff that happens in post-production in the localization side. So if you imagine that each one of those languages has at least two additional assets with it. So there's the one for the voice, and then there's one for subtitles, and then you have to think about things like keeping everything in sync. So there's a whole bunch of work which happens with even like getting second languages to look natural with the way the actor is talking. There's actually a bit within this clip where one of the actors says ridiculo in Latin American Spanish, and the original is absurd. And the reason that they chose ridiculo was because it looks more natural with the way that the actor forms the sound with their mouth. So some kind of cool stuff that goes on there. And did anybody catch how many languages there were? 8. There was 8, yeah. So huge amounts of work goes into that. But the idea is to make a better customer experience for the end user. Because like I said earlier on, people want to watch things in their own native language. So what does this look like from a workflow overview? So basically you have your external post house, which would be like Deluxe, Technicolor, a whole bunch of other partners who we work with. They'll create all of these assets, and they will send us up the deliverable assets to our Amazon S3 bucket. From there, our digital asset management system is watching all of the time for assets that get delivered. Once they hit the bucket, a whole bunch of workflows get kicked off. We actually use a DAM which is kind of intertwined with S3 and EC2, which then goes off and orchestrates workflows to do things like further encoding. So, for example, when you watch an Amazon original show, the very first thing you normally see is the Amazon Studios original logo. Now that's what we call stitched on to the video asset. That's not normally there when the video is delivered to us. So we'll actually stitch that logo on at the very front. And to do that, we use AWS Elemental, as you'd imagine. We do try to drink our own champagne wherever possible, and AWS Elemental actually works very well for us. So we go ahead and we create these deliverables ourselves, and then package them all up using our DAM. And then finally, we deliver those to Amazon Video. And that's really where we pass the baton to Amazon Video, but we're going to talk a little bit more about that later on. So ingesting at scale. When I first started scoping this out, I was kind of like, well, there's a whole bunch of stuff that we can use from AWS. Like, this isn't going to be hard, right? It's going to be easy. There's loads of stuff we can use. So the first thing we looked at was obviously S3 transfer acceleration. Moving stuff into S3 is actually relatively straightforward. It's a bunch of put requests, but performance isn't always great. So we were very keen to test out S3 transfer acceleration, and we did a whole bunch of benchmarking ourselves. We actually went off to Japan, Europe, the East Coast, Sydney, Australia, and India to do these tests because we wanted to see like what would be realistic. We found that S3 transfer acceleration was actually pretty good for us. Snowball was good, but not for the ways we initially thought. So when we first started learning about Snowball, when it was first released, the first thing that a lot of the post-production and production people thought was like, this is great. This can help us with dailies. So dailies, for those who don't know, are essentially the video assets that are created during filming on set during a day. They're then packaged up by what's called a DIT, who sends them up to executives to review. And the executive will look at it and be like, I don't like the way that Titus Welliver has delivered this particular line, or I don't like the way that Jeremy Clarkson looks in this particular shot, like, can we get it done again? And then it gets fed back to the production team. That doesn't really work with Snowball. Snowball, we found, is obviously way too slow for that type of interaction. But where it is really good is for when we're doing archival. So obviously a post-production house or a production house will generate thousands and thousands of assets, like hundreds of terabytes of assets, I guess. And we can throw them onto a Snowball, and then they get ingested into our buckets, and we can do things with them then. The other thing that we found was super useful is direct connect. So once we get stuff into our S3 buckets and our AWS infrastructure, we want to be able to kind of share it with different post-production houses and partners. And so we often use Direct Connect to do this. There's a couple of reasons. Obviously, performance is much more reliable. It's much faster. We can have a 10 gig connection if we want, and we can throw stuff backwards and forwards really easily. It's also private, so we don't have to worry about our content kind of getting out onto the internet, which is one of those things that actually keeps me awake at night. So that's definitely a good option. And then we looked at third-party options and partner options. So when we did all of our benchmarking, one of the key things that we did was actually visit a lot of our partners, and we asked them, like, what is it you want to do? Because we're Amazon, because we obsess over customers all of the time, we obsess over the things that our partners were having to do, because they're our customer as well. And so we wanted to get their feedback as to what would be a good experience for you working with Amazon Studios. And they came back with some suggestions. Obviously, Aspero is a very famous one, Signient, and a Tunity Cloud Beam. So we definitely went there with an open mind, and we looked at the kind of options that we had. What we found with these traditional media ingestion tools is they get really expensive. They have an excellent ecosystem. There's a whole bunch of stuff out there. They're really good, they're really reliable, but they're pretty pricey. They're priced for peak, or the option that you can take is typically it'll be like on the quantity of data that you're pushing through, or it'll be on the size of the pipe that you're putting through. So you might end up in a situation where you have a 10 gig link, but you can't use it because it gets cost prohibitive. So that was kind of frustrating, but it didn't rule out, obviously, third parties for us, but it was stuff that we hadn't really factored in, and that was a big learning curve. Looking at S3 transfer acceleration, it was obviously priced based on transfer. It's awesome when you're near to an Amazon CloudFront POP, but there are some additional considerations as well. The benchmarks we did showed that S3 transfer acceleration didn't actually help us when we were moving from, say, the East Coast over to the West Coast. But when we went to somewhere like India and we started using S3 transfer accelerate, wow, it was blazingly faster than before. So other considerations, we've already established that files can be hundreds of gig in size. So a 30-minute episode is going to run to 300 gig. An hour-long episode is going to be double that. And then think about movies, right? Movie is 90 minutes, 120 minutes. So you're looking at like a terabyte or 2 terabytes in terms of size. We found that there were some things in the cloud which weren't as much of a panacea as we hoped they would be. And we stumbled a few times on a couple of things we implemented, so I'm going to talk about those in a sec. Time is always a factor with production and post-production. Like, this is something that never goes away, never ever gets longer. You never get a longer time window. And doing something differently will often open, the door to unexpected things to happen. And one thing I learned coming into this industry was this industry doesn't like change, fears change, doesn't like it. And the reason for that is because they have this short time window to get stuff done. And so it doesn't like to try things that it doesn't know will work. So you end up in this kind of weird chicken and egg situation. So you'll be like, we need you to try this new way of doing stuff. Why? The old way works. Yeah, but we can do it this way and it'll be faster. I don't know. Like to kind of like highlight this point, one of the first conversations I had with a vendor who has years and years in this industry of experience, his first opening comment to me was, Callum, this cloud thing, it's a fad. So first of all, I was kind of taken aback. I was like, oh, okay, I hope not, because I've spent the last 8 years building my career on this, so I really hope it's not a fad. But it really drove the point home that this new technology was suspicious to him. He was kind of like, I don't trust it because I've not used it and I haven't seen it work. So then I'm like, well, let's try it. Well, no, because we still have the timeline. But how do I show you it's going to work without you wanting me to use it? And so you end up in this kind of weird catch-22 situation. So you have to establish trust somehow, even if it's just in tests or in MVPs, like minimal viable product kind of tests, proof of concepts, just to show them that it actually is still going to work. But boy, they're resistant to change. You also need to be ready to MacGyver. So, or I was going to change this to the A-team, right? Because it feels like the A-team might be a better example. But the idea that stuff will just work is a fallacy, right? It's not just going to work. Stuff will break. You will end up in a, metaphorically speaking, shed somewhere where you have to build a tank out of a refrigerator, right? Because sometimes, like, the stuff that you whiteboard isn't going to work. So you need to be able to kind of think about how to fashion a solution out of other things. So files are hundreds of gig for an episode. We have AWS Elemental Server running. We have our assets in AWS. We know that Elemental can transcode from Amazon S3 directly, which is awesome for us because obviously moving stuff around takes time. We also know that Elemental uses multi-part uploads. We hit some ceilings when we first did this. And so this really kind of threw a wrench into the kind of machine, as it were. So to give you some kind of some background here, we were under the gun to get our original content re-encoded with new logos, new dub cards, new languages, and sent to Amazon Video for the global release of Amazon Video as a service. So that meant we had to take all of our existing shows, of which at the time I think there was 19, and we had to basically push them through a workflow and get this done super fast, which was kind of stressful, to be quite honest. And when we hit this, we found that when we had a file that was 200 gig or more, Elemental would fall over. And so it took a bit of diving in kind of deep on this and talking with Elemental, well, kind of screaming, if I'm honest, like, what's going on? what's happening? And they were like, oh, it's because we set the multi-part upload chunk size to be 20 meg. And I was like, oh, okay, can you make that bigger? And they did, and so after a bit of panicking and a bit of re-engineering on their side, we were able to actually, push past that. But it was one of those moments where it was like, well, how do we get around this? So anything more than 200 gig, it was a failure. So we needed this solution. Localizing to Amazon EBS was going to introduce an additional delay. So remember, that time crunch is still happening. And it's even worse now, because now we've got Amazon Video pushing us to get this content ready, because they don't want to launch Amazon Video globally without the flagship stuff. And who can blame them, right? So there's a lot of pressure coming in. So what we did is we took out our kind of 18 blueprint, and we realized that we can still transcode our assets from S3, but we are going to have to output to EBS. And that was something we couldn't avoid. There was just no other way to do it until Elemental deployed a fix for this. And then we had to upload to S3. So it wasn't perfect, but it was effective. Now, the cool thing about Elemental is obviously it's based in AWS too. So we were able to make up time here by horizontally scaling. So we were able to have more encoders from Elemental running at the same time. So even though we lost time because we had to go from S3 to EBS and then EBS to S3, we were able to do that in tandem with, I think at the time we were running 50 encoders. So we were able to push through all of our content very, very quickly. And it meant that we actually made up time. So what went from a very panicked scream, high-pitched voice from me to, Elemental actually was like, oh, we're fine. This is okay. So it was actually good. But now, we've moved on from that because Elementor have fixed it. And now what we have is everything is done in S3. So Elementor is able to get over the 200 gig file limit size. We're able to forget about moving stuff down to EBS and just do everything straight into S3. So we gain time back. So that time crunch is now less kind of stressful. So to quickly summarize ingest, things that you need to think about. When you're starting to use these bigger files, stuff will start to creak under the strain of it. It's like there'll be little things that come in because you don't expect them to be there, and then putting a big file through will have an impact. Check things like API limits, because obviously you want to keep an eye on those kinds of things. But always test stuff with representative data. Like, it's all well and good to take like a 150 gig file and push that through Elemental, but then the moment you go to 201, it all falls over. So try and kind of test with like-for-like assets if you can. Okay, storage. So you have all of these assets, and you're bringing them all into AWS S3. So essentially what you're doing is creating a content lake. Moving really large files, it's hard. It's hard on you in terms of time. Not technically hard, because you can do this with Signiant and all the other stuff we've talked about, Aspera, Cloudbeam. It's hard because it impacts your production timelines and post-production timelines. This is what a typical workflow looks like for HD. So you'd have your on-premise facility who would upload using something like Aspera, Signiant, Attunity, whatever, S3 Accelerate, pushes it into a staging bucket in S3, a notification is triggered, and then encoders kick off. Any of these will pick this up automatically, and then it pushes stuff to the upstream partner like Amazon Video. So super straightforward and not overly complicated. But let's go back to this again. 1 terabyte per hour, 25 gig per hour. There's a big difference here. So I'm going to say this again because it absolutely is worth saying twice. Moving stuff around is hard. When assets get to a certain size, one of my colleagues coined the phrase, they have content gravity. So in just the same way that like a large space-based entity like a moon or a planet will have its own gravity, so does a large asset. You don't want to start moving that planet or video file around too often. You want to start moving things over and into the ecosystem where that resides, as opposed to shifting stuff around. It's also better for security, right? Because like the more people who start touching your stuff, the more likely stuff could end up where it shouldn't be. So once you get stuff into your lake and you have like the thousands of assets and you have the big assets, someone's going to come along and they're totally going to say, show me what you got, right? And you're going to be like, I don't know what I've got, because there are thousands of assets. If you try and track all the things that come through from a show's production, you're going to have a bad time. Camera files alone, there are thousands and thousands of them. So what can you do to kind of help with that? And well, honestly, metadata is the key. So, and I kind of see a key like this because obviously we use S3, so metadata like being part of the key is absolutely part of the way we address this. And there's actually a blog post which talks about how to pull metadata from your assets. This high-level overview is a serverless environment that you can see. Basically, it has everything that happens. This is actually pretty similar to what we have at Amazon Studios. It's not exactly the same, but it is pretty close. But the key part for this is here, metadata in the assets themselves. So you'll see we have AWS Lambda flagged here, and there's a reason for that. Metadata basically looks like this. It's an XML style file. It contains information like the version number, the location of the file itself or the asset, the format or the codec that was used, and the duration. So there's a whole bunch of stuff in here which you can pull. This is great stuff. It's awesome. You can put it into a Dynamo database or whatever, but you've got to grab it. And this is where it actually gets really hard. So remember how big UHD files are. They're big, right? 2, 3, 500 gig, even bigger for movies. The problem is metadata isn't always in the same place in an asset, right? So this causes some real heavy lifting for when you want to grab that particular metadata. It makes extraction much harder than you would imagine it to be. In a traditional environment, this is what you would do. You would grab that asset, you would transfer it to a processing node, then you would read through that file until you find the metadata that you want, and then you'd output that to a file. So we're in the cloud. We're also using really big files. So moving those files is something we don't want to do. So How about using Lambda? All right, great. We could fetch the file from S3 or a DAM or wherever it might be using a Lambda function. Then you could read through the file, and then you could output, except that you can't. And why can't you? Because Lambda has 500 meg of scratch space. So you can't download a UHD file to Lambda. It's just not going to happen. Plus, you're going to time out. It would take the function way too long for it to get anywhere near through the whole file. So then, again, it's MacGyver time. Because it's all inconsistent, you can't just grab like the first however many bytes that you need. You might not want to put stuff in Lambda anyway, because obviously like there's not enough space anyway, but like there might be infosec reasons you don't want to move it into another service. Costs will go up, and it's seriously going to run out of execution time. So it's not really an option like that. So this is where we use a tool like Media Info. It's free and open source. It's a BSD license. It grabs all of the information of the asset as it needs to. It can export stuff in an XML format, and you can use curl with it. So what this basically does is you tell Media Info, OK, this is where the asset is. You give it a URL, and then it goes, and it looks at the file, and it grabs only the stuff that it needs, and it pulls that back into the Lambda function itself, and then it can export it. So it's actually a lightweight process. And it's also really good because it's statically compilable, so it doesn't have external dependencies. So this makes it ideal for using with Lambda. So obviously, because it's Lambda 2, you can do things like this. You'll push the file to S3. Then S3 sends a trigger notification. Off goes the Lambda function. It gives the signed URL to Media Info. It then fetches the bytes that it needs, processes it all, and then pushes stuff out to something like DynamoDB. Simple. Took a bit of working out, but that's how it basically goes. There's a blog post on this. Have a look. Definitely recommended reading. And also, this types into something we did at Amazon Studios. So remember I told you about all the thousands and thousands of assets that are coming in, right? And the show me what you got thing, right? So there's metadata in every single object that gets uploaded into S3. So what we actually did was a very similar deployment here. We took a Lambda function, which would go and grab the object metadata as it came in, and it then throws it into an Elasticsearch index, which is great, because it grabs the key information, the type of file, and it gives us something for us to look for stuff. So if someone says, like, I want an image file from the Grand Tour, I've got a better chance of finding it because I've been able to grab that metadata. So for us, our DAM has to be able to cope with all of these things. So it has to be on AWS because it has to be scalable. Like, stuff isn't getting smaller. We're making more and more shows, more and more movies, so it has to be able to grow. We have to be able to give access to both internal and external organizations, so it has to integrate natively with them. We want to automate this as much as possible, too. So having an orchestration layer was vital for us. And so creating like the DAM that we have, a key piece was having this automated workflow orchestration. And then finally, delivery and distribution is something that needs to be considered. And because of our arrangement with Amazon Video, they are our primary distributor. We could figure that out with them. But we also have other ones too, right? So if you've ever traveled, which I'm sure you all have, on an airplane, and you've watched somebody in-flight entertainment, there's a good chance you've seen something from us. It would be a movie, or it could be Man in a High Castle, Mozart in the Jungle, whatever. So you'll find our stuff there too. So we have to have the ability to have other distribution channels supported. And this is how we came to the cloud-native DAM. So in a nutshell, this looks similar to the previous diagram, like I mentioned. What we've got are external contributors. So this could be content providers, could be post houses, could be whoever. They receive a task from our DAM. Like, our team will basically say, OK, it's time for you to deliver stuff to us. So we want those assets. Here is a task. The task contains a pre-signed expiring URL. They're able to click on that, and it does a couple of different things. It will either use S3 Transfer Accelerate to just grab the information and push it up to our bucket that way, or it will fire off a Signian agent, and it will actually use Signian to push the stuff to us. And then once that asset has been received by the transient storage, which is an S3 bucket, that task is marked as complete, and they're done. Once it hits that transient storage bucket, the workflow orchestration engine, which is actually Reach Engine, which is created by Levels Beyond, that does a whole bunch of things. So it has its own indexing service, which is built on Elasticsearch. It has the ability to create proxies for us, because what you don't want to have to do is show everybody, the video assets from the mezzanine file, which is ginormous. So we have the ability to create proxy assets, which are a lot smaller. We're able to control who has access. So remember, one of the things we needed to solve was how do we give PR and marketing and legal the ability to look at these assets. We can do that using this particular DAM. And then we're able to kick off orchestration jobs, which will create packages. So if you're familiar with this industry, a lot of people use IMF as the format. We actually use MMC, which is a little bit different. It's still componentized delivery, except that MMC is probably less well-known than IMF. And to make it even better, we use a non-vanilla version of the MMC spec, which Amazon Video created, which made it even more fun to figure out. But we did. And so we're able to create those packages, and then we deliver them to Amazon Video just by using bucket-to-bucket transfers. So that's actually pretty quick. We can scale it up quite dramatically as well. So that's nice. And of course, AWS Elemental is doing all of our encoding that we need, and that's all through REST-based APIs. So just to quickly summarize storage, using HTTP, curl, etc., these are standard things. Like, there's nothing exotic about this at all. Think about cataloging and your metadata early on in the process. Like, the worst thing is to be like, I have got stuff, and I don't know how to show you what I've got, so you're going to want to think about that as early as you can. This last bullet point comes up a couple of times in the presentation. Avoid POSIX requirements. So when we were architecting our DAM, I had a conversation with the guys from Levels Beyond, and they wanted to use S3 Fuse. And I was kind of like, ooh, my spidey sense is tingling a little bit here. If you use S3 Fuse, we're going to have a bad time. And the reason we're going to have a bad time is because there's a whole bunch of assets here. And S3 Fuse doesn't scale well. An fseek and an fopen, like, that's an expensive operation to do. So I was like, probably want to just reference S3 objects. Wow, they didn't listen to me. And so what happened was, in the early stages of the project, everything fell over. Like, the whole thing caught on fire. And I was like, see, told you. Gotta listen to your SA. So what should be on here is listen to your SA. But yeah, so avoid those POSIX requirements as much as you can. Processing, right? Because this is the 400 level, I'm not going to try and teach you all how to suck eggs, because you're all going to understand this. So processing things faster. There's a couple of ways, well, there's 3 ways you can basically do this, right? Vertical, so this is where you take a large instance type and then you use a bigger instance type, right? Very similar to the physical world. You'd have your physical server. It has a finite amount of resources, and if you run out, you buy a bigger one. The other way is horizontal. This is when you have instances that you scale out like this. So instead of having 1 or 2, you go 3, 4, 5, 6, 7, 8, whatever number you need, and then you're able to do things in parallel. And then finally, there's this concept of a diagonal. So when you scale diagonally, this is a little bit interesting. So this is where you go from a particular family and you move to another family to see whether or not you get better performance. So in this particular example, M4 to C4, or M5 to C5 to G2 or G3. So the trick here is to do some benchmark tests and see if you get better performance from these different classes of family. So just to focus on diagonal, a good example is obviously GPU encoding. So back in 2016, the state of the world was like this. You had G2 processors, which were based on the NVIDIA Grid K520 Kepler chipset. The important thing to note here is you could do H.264 encoding, which is great. It's a very, very common encoding type. But you couldn't do HEVC encoding, which is actually UHD, right? This is the 4K part. So you couldn't do this at all in 2016 with G2s. But now we have the G3, which has the Tesla M60 chipset. And as you can see, that green box thing now includes the Maxwell GM20X family of chips, which does support HEVC. So if you were going to do some kind of tests and stuff on encoding this, you could absolutely use the G3 instance type. Couldn't do that last year. But let's go back to vertical. So we had a bit of a play with some benchmarking for this. We tested M4 large against M4 16 extra large, right? So pretty big instance. As you can see, there's a big difference in performance. For the M4 large, we were getting 0.61 frames per second out of our tests. For the 16 XL, you're getting 8.78, so almost 9 frames per second, which is a significant improvement. It's also a significant price difference too, right? So it's a little bit pricey. So then if you diagonally scale, let's check out C4.8XLs, and then you get almost 7 frames per second, but it's only like $1.59. So these prices are actually from this week. So, always got to keep an eye on the prices because sometimes prices will drop, and these tests become kind of a little bit different. But you can see you've got almost as good performance from a C4.8XL than you get from an M416, but it's almost half the price. In fact, that is half the price. So, it's a pretty good way to think about it. And that's where diagonal scaling can really help you. So this metric here, this is the amount of hours processing that you need for 1 hour of content, right? So on a C4.8XL, for every hour of content you need to encode, you're looking at 3.6 hours. So that works at like $5.72. 2.7 hours for the M416, but it's significantly more expensive. So this is where you do your cost-benefit analysis, and you think, well, okay, it's almost as quick, but it's way cheaper, so I'm going to go for that option. So being creative with instance types is definitely worth trying, so we recommend doing that. The problem with vertical scaling is you can do a whole bunch of multi-threaded processes, right? The issue becomes if you lose one of those threads or one of those processes, you lose that entire job. So imagine like you're 3 hours into a 3.5-hour job and a thread dies and falls over, you got to start all over again. And that's a bummer because that time kind of demon, which is behind you stalking you because you need to deliver it, is still there. It's getting closer. So, you've got to think about ways you can get around this. There's also upper limits on scaling. Like there's massive instances now, but there is a ceiling in instance types. So this is where we think about horizontal scaling. So people associate this, with well-established architectural patterns in AWS, but it's one of the things for video which is a little bit harder to do because video files are a little bit special, but you can do it. If we break down a video file into a very, very simplistic overview of it, it's essentially a container. Within that container, you've got metadata, you've got the video asset itself, the video stream, but you've also got audio streams too. If we want to break these down, we could potentially have one video stream with the 2 audio streams, and we could create separate encoding jobs for those. So audio streams are a lot smaller than a video stream. So you don't get a great deal of benefit by doing that. But the video stream, if we could think about a way to actually break this down, we could potentially do huge things in terms of performance. And that's exactly what you can do. You can break down your video stream into a whole bunch of different chunks and then run encoding jobs on each chunk. So you would actually get a huge amount of performance improvement. So you're parallelizing it at the chunk level. So basically what happens is you read the file, you start encoding a specific length with the offset, you then output that chunk to a centralized location, something like EFS or S3. Remember, don't use S3 Fuse because it will just be a horrible performance nightmare. And then a collation node is going to group all of those back together. So to actually do this like really quickly and walk through it, you use something like FMmpeg, which is really a jack of all trades, Swiss Army knife tool that you can use. So in this example, we're basically just creating chunks of 60 seconds. We're splitting stuff up, we're giving it some parameters, and then it creates an output file, which is a TS file. So you split the load up, and then you prepare for concatenation. So you've got your list of chunks that you've created. You basically would then create like a manifest itself, and then you would pass this back to FFmpeg on the collation node. It would then concat them all together, and then reassemble the chunks into one video file. So you've got all of these encoded video chunks, concatted all together, and then you've got your video stream back. So if you can do this across multiple nodes, you can imagine how much quicker this is than doing it on one vertical node, like where you're just scaling in terms of like vertical size. Alrighty, and then you redeliver back to the container itself, and then you're done. Now, you're probably sitting there thinking, this sounds awfully familiar, Callum. This sounds a lot like EMR. Because that's essentially what we're doing, right? We're creating a map-reduced job. We're taking a very complex problem with a big file size. We're breaking it down. We're doing the mapping piece. So every individual encode is essentially the mapping function. And then we're doing the reduce, which is the concat filter. So absolutely fits in alignment with EMR. So there is potential to actually do this using EMR. And then you'd have a whole bunch of manageability too. So totally doable. And the whole point of that is When you have like new problems, like you're trying to do in codes like this, look at some of the established tools that are there already. Things like EMR might be great fits for this type of work. You're able to get like parallelization, which is good for in terms of resilience. So if something falls over, you can just retry that one particular piece, that one particular encoding job, instead of having to start from scratch. And keep an eye on your AWS instance prices. When you do your tests, it's going to be this much cost-benefit analysis, but stuff changes over time. Which brings us to the last section, which is distribution. So, distribution techniques, there are many different platforms. Delivery is actually very similar to ingestion for us. We use a lot of the same things, like we use Signient, we use S3 transfer acceleration, but it also depends on the customer too. So for us, it actually works, our customer being Amazon Video, super easy. But for them, like they have a whole new kind of like range of challenges. So Amazon Video has to deliver to customers who have different devices. They might be in different physical locations. They might have really good internet. They might have really bad internet. So they have to factor all these things in too. So at a very base level for us, bucket to bucket, super easy. Transfer accelerate, absolutely easy. And then obviously Signient helps us no end. But when you want to come to your viewers and you want to start like, streaming to them, the standard approach is obviously to use a CDN, Content Delivery Network. And you can use adaptive delivery here. This is all super common. Amazon Video does this, Netflix does this, I'm sure Hulu does this too. And the idea about adaptive delivery is it's able to adjust the quality of the video that you're actually receiving. So what does that mean? Well, in adaptive delivery, think about it like this. You have a manifest file, which contains the stream itself and the quality itself. So in this example, you've got a 1024 and a 2048. So for a lower bandwidth, you'd be using the 1024, and if bandwidth is much better, you go to the 2048. Everything else is the same, but the quality is obviously different. So you have a series of chunks, which are then streamed to your end user. It looks like this. So the client has their app, they fire up Amazon Video, they decide they want to watch, I don't know, The Tick, which is awesome, or Jean-Claude Van Johnson, which is also awesome, by the way. So it takes chunk one, and it'll actually pull that, and it will be able to stream chunk one to the device. Chunk two the same, but what typically happens is, and I don't know if you've noticed this, I've certainly seen it a few times, it drives my wife crazy. The first chunk, or the first section, is always lower quality than the rest. And the reason for that is because they want you to get the content quicker. So they'll send you the lower bit rate first, and then it gets better as it adapts. So it then moves to like the second tier here, which is chunk 3, 4, and 5. It's harder at 4K, but it's not impossible. The challenges are still pretty much the same. Again, it comes back to that ginormous problem issue, the sizes of the files being bigger. Ideally, in any content delivery, you want to keep it closer to your end users if you can. You end up getting cache width problems, and assets will, age out quickly. And then you're constantly racing to face the next chunk every time that you have this situation. It's actually gotten a lot better over the last 12 months because AWS has released CloudFront regional caches. And I think they're up to like 96 POP locations now and 11 regional caches. So there's a lot bigger global network. But there might be reasons that you don't want to use that. This is what it looks like as you move stuff closer to your users. Between S3 and CloudFront, connectivity is typically very good. It doesn't matter really where you are in the world. Connectivity between S3 and the POPs is always going to be pretty solid. But when you start moving global content, and you've got viewers who are in, I don't know, like Outer Mongolia, right? Or India, or somewhere where, like there might be an Indian countryside where they're looking at their devices, like their phones, and they're using like their cell phone service. You're going to have a problem with things like latency. Just the sheer rule of like the speed of light is going to make it hard. So when you've got a bucket in US East 1 and you're serving content to people who are in like Iceland or, I don't know, South Africa or somewhere, you're going to have that speed of light problem. So this is why you want to bring your stuff closer. The problem is cross-region replication sounds like it would be a good option, right? So cross-region replication, you have a bucket in US East, and then you have a whole bunch of viewers in Mumbai. So you basically replicate that over. And then you've got your bucket in Mumbai and your bucket in the US East. You're bringing your content closer. The issue then becomes, though, you can't chain cross-region replication. And the reason for that is because buckets have to have unique names, okay? Like you can't have like, Callum's bucket in multiple different regions. It would just break stuff. And then CloudFront needs a domain name as an origin. So this makes it super complicated in terms of like chaining it. So you have to look at a different approach. And for that, there's a customer from AWS called Spool, and they actually did this in Singapore. And essentially what they did was they layered inside EC2 like a whole cache. And they built this using Nginx and EC2. They use Lua and AWS Auth. And what they essentially ended up doing was creating this kind of middle tier. And the idea was, instead of relying on CloudFront, they built an intelligent caching layer where a user would basically send a request, and then they would pull the asset into EBS, and it would be able to stream a lot quicker from there than if they were doing it straight from CloudFront in their S3 bucket. The cool thing about that, too, was they only did it when needed, so it actually reduced costs. And because they had direct access to the OS and Nginx itself, they could actually put more logic into it, which made the service even better. The intelligence in Nginx provided for that experience, but then they were still looking at ways they could further improve performance. So coming back to this model again, you've got the chunks on the left. The first chunk, chunk 1, is the first one that gets served. And then you've got the following on ones where you've got the 2 tiers of quality of bitrate. So what if we could prefetch that? Well, this is exactly what they did. Lua made a system call from Nginx, and it creates a URL which is persistent, which they can queue. It then passes that to a queue worker, which reads the queue. It builds all possible URLs that could be needed. They can then execute curl against the local node, and they can pull the content in. So instead of having to wait for stuff to be pulled in, it's already there. It's already preempting what they're going to need. They can have the next 2 segments using the same rendition. They can have one rendition higher if they need it, or one lower. So they're able to account for all different bitrate requirements that they need. And this had a dramatic impact in terms of performance for them. So the transfer speed initially before they did this, you're looking at 4.3 to 5.2 seconds. And then the speed itself, averages around about 9 meg per second. After they put the mid-tier in, you're looking at 103 megabits per second for doing the actual operation. So this is a dramatic performance improvement. And it's an example, really, of being creative in using AWS services to really push the envelope in terms of speed. I mean, now you can just use region edge caching, right? I mean, it's there, and it's there by default. You don't have to do anything. It's just going to be there when you start using CloudFront. But if for whatever reason you don't want to do that, then putting in a mid-level tier is definitely a good way to think about it. So to quickly summarize, feed that fire hose globally. It's pretty tricky. It's a belt and braces type of approach. You might put a caching layer in. You might use CloudFront regional edge locations. If you've got a layer already in there, look for something else that you can put on top. And again, use CloudFront region caching. So to wrap it all up, when you're doing ingest, it is not. Okay, things break at scale, so test at scale. Make sure that when you're putting stuff in place, you use data and assets which are going to be like your production ones. Otherwise, you're going to get caught out when it comes to production time. Avoid using POSIX requirements. Process stuff intelligently as it comes in. Look at your metadata, start to catalog early on. Parallelization definitely helps solve many problems. So if you can scroll, if you can kind of scale outwards instead of vertically all the time, then you'll be able to run jobs simultaneously. This is exactly what we did with Elemental when we were under the gun for delivering our content. So we were able to run all those jobs in tandem. And then finally, feed the fire hose and reuse layers for good. So make sure you build in a caching layer if it's appropriate. Use CDNs like CloudFront, and keep your data as close to your customer as you possibly can. So 4K has the same problems, but it's at a scale which really cracks existing systems. It really puts strain under them, and it's really difficult to kind of imagine what that's going to be like until you actually do it. Many of the same approaches will work, but you have to have your MacGyver kind of hand tool ready to go to really think about how you do this. Space is very new, and technologies are still catching up, and this is absolutely true of the industry as a whole. People don't like change, especially in a very intensive, deadline-driven environment like production and post-production. So you really have to make sure that anything you put in place works and demonstrate it. So wherever you can, run a proof of concept, run an MVP, and be able to say, like, I know you don't want to do this, but we did this with some test stuff, and it totally works, so can we try? And in that way, people will believe in your solution. And that is about it. So thank you very much for your attention and for coming along. Please fill out your evaluations. Thank you.